Hooray! Data Science Nigeria marks 5 years of transformational impact. It has been 157,680,000 seconds of running an award-winning and high-impact artificial intelligence learning, research, solution delivery, consulting, and AI startup incubation network. Let us celebrate some of DSN's major milestones. Over 500,000 learners have benefited from the DSN's free online and offline training sessions in artificial intelligence, data science, and digital skill-related classes. The organization runs the most expansive network of AI learning delivery in Africa, with 41 physical learning communities in cities and on campuses. It also organizes annual Pan-Nigeria AI introductory classes across multiple cities through its AI Innovation project. It currently has an online learners network in 49 countries across the world. Data Science Nigeria, through its founder, Bayo Adekombi, published the first AI book for kids in Africa. The book uses cartoon-like characters to demystify and simplify the basic concepts of AI and Python programming. The book is currently being distributed through a nationwide Train the Teachers program to ensure that every child has the foundational knowledge required to competitively prepare for the fourth industrial revolution and the future of work. The annual DSN All-Expense Paid Bootcamp has become the numero uno of AI learning in Africa. It brings together some of the best global experts who visit Nigeria physically or connect virtually to teach and mentor young African talents. Each AI bootcamp starts with thousands of participants, with only 400 best participants making it to this intensive learning session. The 2021 edition had learners from over 20 countries. Today, DSN has become the biggest talent recruitment pipeline to leading organizations in Nigeria, providing access to top talents who have been trained through DSN's intensive, hands-on and industry-ready training modules. DSN has also validated its technical capability in the areas of consulting and solution delivery. It has successfully delivered over $6 million worth of professional service for leading global multinationals and development agencies like Bill and Melinda Gates Foundation, World Bank, MasterCard Foundation, Chevron Nigeria, AI Commons, KPMG, Access Bank, and so many others. DSN remains very strong in artificial intelligence research, with over 13 academic papers published and accepted at peer-reviewed conferences. The inspiring works of DSN have been showcased at all the world's leading AI conferences. From NeurIPS to ICML to ICLR to Deep Learning in DABA. DSN's work in AI for social good was a case study of excellence at the foremost conference of the Association for the Advancement of Artificial Intelligence held in New York, USA in 2020, where the founder of DSN spoke as a keynote speaker. DSN AI Lab in Lagos is generously supported with research robots from the Computer Science Department of the University College London, complemented with a world-class research workstation donated by NVIDIA. DSN is proud to have won the academic poster at the 21st edition of the ACM Conference on Economics and Computation, EC20, the world's premier conference on the interface of economics and computer science, organized by the Association for Computing Machinery, United States. DSN also won the Best Runner-Up Poster Award at the Deep in DABA in 2019, Africa's foremost AI conference, where the effort of Data Science Nigeria was also recognized with the prestigious Wangari Maathai Impact Award. DSN's work has been acknowledged across the world as a best practice in talent building, indigenous application of AI, community development at scale, early education in AI, and AI for social good. Its work has been reviewed and referenced by the World Economic Forum, UNESCO Science Report 2020, UNICEF Reports, African Union, Data.org, and many others. DSN was the only African finalist at the X Prize Algorithm for COVID Prediction competition. DSN was also part of the National COVID Intervention Team on the use of advanced epidemiological machine learning algorithms to flatten the curve. DSN runs a startup incubation center dedicated to artificial intelligence with a current cohort of 12 startups at its new center in Yaba, Lagos, Nigeria. DSN has transited from the generic theory of AI into practical solution development with a focus on how to apply AI at scale in emerging markets. During the COVID-19 lockdown, which created a major learning disruption to many students in Nigeria, DSN invented an adaptive artificial intelligence learning algorithm which was leveraged to deliver effective and interactive learning through basic SMS, feature phones on 2G network, and interactive radio platforms. This effort helped many learners who have no access to the internet or smartphones. Over 8 million learners benefited from this intervention through the funding support of the MasterCard Foundation. DSN has been a revolution with many firsts of its kinds, like the AI Summer School for Kids, Inter-University Machine Learning Competition, AI hackathons for top organizations, data scientists on demand, AI tutors on demand for primary and secondary schools, AI knowledge box of 20,000 learning videos, free AI for beginners free ebook, and its current effort to set up AI libraries at all the top Nigerian universities. As DSN marks its 5th anniversary, it is making some big, bold transition under its 5 Perfect Transition mandate to re-strategize for the future. The organization is recalibrating its vision and mission with focus on enabling 1 million AI talents in Africa and building AI solutions that will enhance the quality of lives and well-being of people living in emerging markets. It is a double-fold impact transition. Let us reflect on these big 5 shifts. Number 1. DSN is transiting into a global operation beyond Nigeria under the DSN brand name, that is Data Scientists Network, with an existing learners network in almost 50 nations. DSN has become a global knowledge delivery network for the world. All its local and global extensions will now answer the DSN brand name. Number 2. DSN will run a dual business model as a social enterprise with DSN Foundation Nonprofit and DSN AI Innovations Limited, both in Nigeria and in the United Kingdom. This effort will position DSN for sustainability. Number 3. DSN is also changing its consulting model by becoming a distributed talent company. It will run a globally diverse network of expert consultants and partner companies who will collaboratively work with DSN full-time in-house staff to deliver world-class solutions under its new partnership program. Number 4. DSN is launching its learning network with more frequent online masterclasses, project walkthrough sessions, hands-on expert research sessions, and mentoring. These will be facilitated by some of the world's best experts. This expanded learning will also include dedicated programs for professionals, kids, researchers, and developers. Number 5. DSN AI Innovation will be unveiling Spot On, its geospatial AI precision analytics solution for retail and fintech, and ULearn, its AI-powered augmented learning platform that activates learning for every child. DSN is currently building more high-impact products in health, financial inclusion, agriculture, and others. It is a new season at Data Scientists Network, DSN. As DSN unveils its new logo to reflect its global positioning and expansion beyond Nigeria, the organization remains very committed to delivering high-impact AI solutions across the world while expanding its free training and research network across many countries. Welcome to the future with DSN, powering 1 million AI talents and delivering transformational AI solutions for 2 billion people in emerging markets. The 5th DSN anniversary.
Okay, so you're welcome to today's mentorship session. So you can simply drop your name and where you're joining from the chat box. Okay, so going straight to the business of the day, I would like to first introduce DSN to us. Okay, so DSN is committed to raise a millionaire talent and build AI solutions that improve the quality of life and well-being of 2 billion people in the emerging market. So we do this by a renewed focus on 3 core areas, which are number one, community for learning and research, product development for social impact, and partnership for solution delivery. We have evolved over the years from learning and community. We have gone further to research and social good application, also to corporate support and solution development. And now we are now into startup ventures, AI vertical partnership, and AI for national development. Now, DSN won the Material Impact Award at Deep Learning in December 2019. Yes, as the number one artificial intelligence learning community and solution delivery network in Africa. So we won that award in 2019 at Deep Learning in Daba. Also, our paper, our poster won the best academic poster at the 21st edition of the Global Economics and Competition Conference. Yes, our poster was Shared Trust to End Poverty and Promote Financial Inclusion. And then also to reinforce that, we are the only African finalist at the 21st X Prize competition on building advanced AI algorithms to address COVID-19. The data just to reinforce our research and then our learning. It's DSN, we learn and also we carry out research because we know that before innovation is what is research. Okay, now we present papers in global conferences, global scientific and artificial intelligence conferences. That's our lead mentor, Dr. Bayo Adekombi, presenting one of our academic paper in a conference. Now, as I've earlier said, that we are focused on 3 core areas, which are learning and research, products. Yeah, so this is 2 of our products that were initiated by us. That's the EduTech AI adaptive learning engine and the prescribed right was actually selected in the 2021 Global Top 100 AI products by UNESCO. I'm sure you're excited about to hear this. You can just drop your favorite emoji. We are doing great. Okay. Now we unveiled our data fluency platform. So what's data fluency? Data fluency is actually the capacity to absorb data and information and gather insight from this knowledge to boost decision-making process. So this solution will actually help it actually help your data fluency, help your organization to know your data readiness. Yes, how ready is your organization to use data? So you can actually access it on datafluency.sciencenigeria.ai. Now, we want to catch them young at this end, and then lead mentor, authored a book that's Beginners Artificial Intelligence and Python Programming for Primary and Junior Secondary School. Wow, yes, I know it's wild, but we just know that at this level they can get it fast and they can start doing great. Okay, and so that's why we created a resources that simplified artificial intelligence and Python programming language for grade 4 to 8. So we are the first to do that in Africa, and then we can get a copy from Amazon and other stores as listed on my screen. We have a dedicated AI research lab located in Yaba, Lagos, with a training room a robotics lab, and now a co-working space. Yes, a discount is on, which will be closing tomorrow. Yes, okay, ending of July. So okay, so you just get yours as soon as possible before this discount ends. 25% discount. That's huge. So. You're welcome, and then you can just click on that. Use this link to get to book a working space with us. DSN supported by world-class advisory board led by Dr. Who's Stewart and others who are doing excellently in the AI ecosystem. Okay, so today I will our mentor that will be taking on today's section. I would like to introduce him. Okay, before he comes up to take the section. Okay, so Dr. Dave Ojika, an AI infrastructure and system engineer at Flapmax. Okay, so Dr. Ojika is an AI infrastructure and system engineer at Flapmax with a PhD in computer engineering from the University of Florida. Now, he is passionate about building technology innovation that helps solve poverty, bring good health care to the underserved populace, and put food on the table in abundance for those that need it most. Okay. His industry and research interests span abroad the areas of distributed system accelerator and scalable system design that for data intensive computing, including big data and machine learning. With 15 years of experience in software development, architecting, and leadership combined. So he has 15 years of experience in software development, architecting, and leadership. So let me welcome on stage, Dr. Dave Ojika as they take on today's section. Please, your favorite emoji as to welcome him. Okay, to welcome me to take the next section.
Hello, hope you're all doing fine. Welcome to this presentation. This is a joint partnership between Data Scientist Network and Flapmax. My name is Bernard Irongo. I'm a Senior Programs Manager at Flapmax. I'm delighted to go through this talk on artificial intelligence, and I hope that this talk is going to be beneficial to you. I'm going to talk about AI tools, platforms, and use cases. And this is going to be a first part series of 3. Hopefully the interaction is going to be beneficial to you all. So I'm going to start with the objectives of this session. 1 is to introduce machine learning concepts. 2 is to recognize the different AI tools, platforms, and application use cases. And 3 is to point you in the right direction as far as hands-on guide and learning path for navigating and mastering the platform. So this is supposed to serve as an introduction to AI, and along the way we are going to cover more and work on some practical approaches. So I'm now going to move on to a short introduction of Flapmax. Flapmax is an edge computing company, or at least a cloud computing company, which has been working within the AI ecosystem for a couple of years now. And one of its integral programs or institutions is the Flapmax AI Institute. This is an organization that has been designed to nurture and develop skills from a wide pool of talent. Among the talent that we are sourced is through our partnerships with different universities and industry players. These include Purdue Global University, Korea Institute of Science and Technology, and the University of Florida. Our partnership has grown through the years that at the moment we are now in our 3rd cohort with Purdue University, and we're looking to jump into another cohort with the University of Florida and KAIST University. Our great success so far has enabled us to partner with industry giants across the world, including Data Science Nigeria and including Data Science Network in Nigeria. And this new partnership, I hope it's going to be as graceful and enabling to you as it is going to be, as it has been so far for us. I'm looking forward to working or interacting with you through this live session and the interactive session later after this presentation. The AI Institute is also in partnership, or rather, Flapmax as a company is in partnership with Microsoft, and we have deployed the first ever African focus-based accelerator called the FAST Accelerator. The accelerator received over 800 plus applications, and we had an acceptance rate of only 1.2%. And through this partnership, we are working as an AI enabling company, and we are more than grateful for Microsoft in partnering with us in this endeavor. So let's start then. I'm going to start with the definition of AI. Artificial intelligence is when a machine mimics the cognitive functions of a human mind. Now, I figure for most of you on this talk or listen to this live recording are aware of the basic description of what an AI is. And that is pretty much it. An AI is a solution that is that basically learns or mimics what cognitive functions of a human mind in order to solve a particular problem through reasoning and knowledge representation, social intelligence, and general intelligence. So there are several tools that are used in AI, including versions of such. This is for collecting information, mathematical optimization, logic, method-based probability, and economics. And in AI, there are a couple of subfields that we are going to talk about in technologies. Among the very common one that most of you have probably heard of is machine learning. And then you also have deep learning, and you also have natural language processing or natural language understanding. In majority of these cases, or these technologies, the solution that is built is either a pre-built algorithm and code frameworks, and I'm going to review a couple of those later on, or an automation solution. So all of the above the AI subfields pretty much are built to bring out the solution after the development phase. So let's talk about some of the AI platform providers, at least just to understand the ecosystem. I'm going to start with Microsoft Azure. So this is a cloud-based advanced analytics designed to simplify machine learning for businesses. As you will learn later on, most of these AI platform providers, they have been designed to ease the work of the programmers and businesses in general. So for Microsoft Azure, they have Azure Communities Services, Azure AI Infrastructure, and Azure Machine Learning. All of these technologies have been built or pre-built to enable developers and business owners likewise to improve on their AI adoption. For instance, in Azure AI Infrastructure, you have very competitive technologies there, such as the SGX enclaves that enable developers to run machine learning models in secure environments. You also have Azure Cognitive Services that enable developers to build chatbots that use language understanding. You also have Azure Machine Learning environments. All of these are available for developers as a platform. And also, Microsoft Azure goes ahead and provides business users models that have been built. Basically, these are class algorithms that have been tested in their own internal programs for developers to extend and build further. So some of the class algorithms that have been provided for Microsoft Azure developers include those that have been used in Xbox, Bing, the browser, and some of the Python packages that they have used. All these also have been packaged under the R programming language and Python codes or Python programming languages to ease on the research work for the developers. You also have Google AI Platform. So the Google AI Platform eases the process of ideation to production and deployment quickly and cost effectively. Likewise, Google AI is a platform that provides developers with solutions and research work that has been developed by Google over the years. Now, if you really don't want to use Microsoft Azure or Google AI as a package you want to do from scratch build, you could use either of these technologies, which include TensorFlow, PyTorch, and Keras. So TensorFlow is an open source software library for machine learning. It is an ecosystem of tools, libraries, and community resources that have been developed easily to build and deploy ML-powered applications. In general, what TensorFlow does is it eases the work of a developer. It provides the developer with data flow diagrams and pre-built libraries, meaning that you spend less work or you spend less time doing most of the coding that would have been spent testing and debugging large amounts of library. Spending more time building the final solution. And so one of the big advantages of TensorFlow is graph representation, mathematical operations that you can apply easily rather than building a package or file to code in your mathematical formulas. You easily use the TensorFlow libraries to do that. And there's graph edge representation, multi-dimensional data arrays called tensors. This is actually applied across the board, and using TensorFlow you have that advantage. Then you have PyTorch. It is an open source machine learning framework that accelerates the path from research prototyping to production environment. Likewise, while using PyTorch, a developer doesn't have to pre-build some of the libraries. And with PyTorch, you also get additional tools that you could use to improve on your solution, such as distributed AI building. So you could use PyTorch in a distributed environment where you have an AI model that can be built in a different location and another AI model that is being built in a different location, and these two can be merged in a federated learning environment. And then there's Keras. Keras is a deep learning API, and this API has been specifically built for the data scientists. It has not been built for the machine learning model, and it eases the cognitive load that a developer has to use. So it offers a consistent and simple API, meaning that a developer or user actions require common use cases, and use cases are going to be a very common phenomenon as well you're working with artificial intelligence. So let's look at the AI ecosystem, and we're going to start with the applications. So for instance, with image recognition, I figure this is something that is very common out there. The idea of taking a photo, running it through an AI model, and then identifies this is a shirt, this is a trouser, this is a dog. And then there's speech recognition. This is very common in our smartphones with either Siri or Hey Google. You have chatbots. This is very common on websites. Once you open a website and then there's a chatbot there, you're chatting with the HR person. All these are very common. And then there's model types. In the AI ecosystem, you're going to have deep learning networks, you're going to have machine learning networks, and then you have the neural networks. So the neural network here is the fundamental requirements as far as an AI goes. And then you have the programming languages. Among the most common programming languages within the AI ecosystem is Python, which is followed by Java. Python taking the precedence here as the most common and easy to use programming language. And then you have the software and hardware frameworks. So I've spoken about TensorFlow, PyTorch, and Keras. You're also going to have GPUs. And with GPUs, some of these frameworks, so for instance, PyTorch, make it very easy for a user to use GPU, because with PyTorch, you can run a model on the CPU or the GPU. You can pretty much point to a hardware resource. And then there's cloud data storage and compute platforms where GPU is offered and CPU is offered. Like I mentioned, you can access these through Microsoft Azure platform alongside other technologies. So with that ecosystem in place, how does this interface with the clients? So supposing you're working on AI, what are some of the industry applications of AI? I'm going to start with AI in healthcare. So there's clinical decision support systems. One of the very common types there is the IBM Watson. And what this system does, it is a system that collects information from a user, and it helps a user, in this case being a medical practitioner, it helps the medical practitioner make informed decision. In common research spaces, it's called evidence-based treatment. So this clinical decision support system add on to the cognitive skills of a doctor or medical practitioner. In businesses, you have customer relations management or CRM tools. These tools enable a business to profile a customer based on their interaction. So for instance, you are an insurance company and there's a customer who pays this premium and collects insurance on this. Using these CRM tools, you can pretty much rate this customer or rate this individual. In education, you have chatbots. Chatbots are broad definition. In education, you have chatbots that can rate the interaction of a student or a learner with learning materials in a specific website, which is a very interesting use case. And then in finance, you have price prediction models. So these price prediction models will in majority of the cases use data crawling tools, and they're going to look at the purchases or the demand of a particular product based on current market prices and previous market prices, and then make a price prediction, which will enable investors to know where to invest or how to change their manufacturing. In manufacturing, and speaking of manufacturing, there is also AI application. In this case, you have robotics, which is very, very common in car manufacturing industries, and which is the robust view. However, robotics has been implemented in so many other manufacturing fields. And then you have AI in transport, and this is pretty much obvious with autonomous cars. Well, autonomous cars are not legal so far. We have seen at least cars that assist drivers such as Tesla in making driving more seamless. So then we now jump into predictive analysis process. How does this all come together? So when building an AI model, or working with artificial intelligence, the step-by-step procedure is define the project or come up with a problem statement. With the problem statement, then you collect data. So you have the data collection process. This is where you work with your data sets, and then you work on the data analysis, statistical analysis, predictive modeling, predictive model deployment. Now, all these has been packaged into artificial intelligence, and through these definite steps is where you work with machine learning. And so let's jump into machine learning as a subfield of artificial intelligence. So machine learning, as the name suggests, is a scenario where you use a computer to learn or to pretty much train a particular model. So the computer in this case is learning how to do particular tasks. And so there are different ways in which a machine can learn. And some of the common ways, or a very brief introduction, is supervised learning, which is task-driven and predicts next value. You also have unsupervised learning, which is data-driven and identifies or learns through clusters. So it clusters information. All these look closer to this, or these look closer to this, and it keeps everything in a particular group. And then you have reinforcement learning, and this is learning from mistakes, and it is based on an environment and an agent. With reinforcement learning, it is based on positive reinforcement, where a computer will learn, and then if it's positive, it goes in that direction. If it's negative, it changes the direction. So this is just a broad introduction into what the ecosystem looks like. And now we are going to look at the expanded list of machine learning types. So a machine can learn in a supervised manner, like I mentioned earlier, and while it does so, it can use dimensionally reduced mannerism, or it could use regression or classification. It could also learn in unsupervised means, where it goes with the k-nearest neighbor or the hierarchical clustering. It could also use reinforcement learning, and while it does so, it can apply all these different algorithms. So under supervised learning, you have dimensional reduction algorithm, you have the regression algorithm, the classification algorithm. All these different algorithms provide value or characteristics to these machine learning types. You also have neural networks. So neural networks here are a fundamental requirements or a prerequisite to using any of these other machine learning types, because for you to have a machine learning environment, you have to have a neural network. And with neural network, you can have a convolution neural network or a recurrent neural network. So let's jump into some of the very common or very basic machine learning types you could use. And so let's start with neural network. Now, a neural network is an algorithm that mimics the human brain in trying to understand the relationship in a set of data. And a neural network refers to a system of neurons, either organic or artificial in nature. So the network in this case is a number of nodes in a specific computer file, and these different nodes try to classify data and find similarities. Basically, it mimics the way human beings think. On occasion, our mannerism in classifying data is how we understand the difference between different animals. So I'll give you an example how we classify cats, and we say we have big cats, we have domestic cats. So we have the leopards, and then you have the cheetah, you have your regular cat at home. This is the same way that AI works. We have different animals, and then we try to group them, and we try to find a relationship between these different sets of data. And with a neural network, it typically consists of an input layer, a hidden or processing layer, and the output layer. So a neural network has to have these different layers in order for it to be classified as a neural network. And so we're going to look at some of the common or very basic, easy to use types of neural networks. For starters, you have convolution neural network, recurrent neural network, and deep neural network. So these are the very common neural networks, and they're very easy to apply, especially if you're a beginner. It's going to be very easy to adopt into different use cases. So let's start with with these different neural networks. Note that while you're choosing a neural network, it has to correlate, or the characteristics of this particular neural network has to correlate with the type of learning you want to use. So the characteristics of this neural network has to be embedded, or it has to be similar to, it has to be compatible with the learning, the type of machine learning you would like to use. All right, then I'm going to give a very brief introduction or brief description of these neural networks. So the recurrent neural network basically means that it learns by going back and forth, checking and rechecking. Deep neural network, as the name suggests, is a case where you use a very big sample of data sets to understand more, or to critique more the data that you're using. And then for convolution neural network, it is a more conventional way of learning, where you move from step A to step B to step C. Now I'm going to explain these neural networks further as we move along. So let's jump into supervised learning. So supervised learning, it is a type of machine learning in which machines are trained using a well-labeled training data on the basis that the machine predicts the output. So note that with supervised learning, you have to provide labeled training data, and the machine is going to learn specifically based on the labeled data. So it cannot learn anything outside the labeled data that you have provided. It is more of a constricted learning environment, and it is supposed to provide more accurate information or more accurate prediction based on the input. And some of the very common areas of supervised learning application is image classification, risk assessment, spam filtering. This is very common in your emails. So with a supervised learning environment, for instance, Google will use this particular learning environment to say that this email comes from an individual outside your outside of your regular persons who you mail with, and so this can be classified as spam. Or in this particular environment, multiple people have considered this to be spam, so if it comes to it's supposed to be spam as well. So spam filtering adds to risk assessment. And then there's image classification. So in the case of image classification, you provide labeled data. So you provide this is a picture of a shirt, this is a picture of a trouser, this is a picture of a hat, and then using that labeled data, you can then collect a group, a large photo or a large directory of photos, and then using that large directory and using using the labeled data, you can classify these new unlabeled data. So you can then use this labeled data with your shirt, trouser, and hat, and then go collect a random group of photos, and then classify that, and that will be supervised learning. You build that model to learn and to classify images. So let's jump into supervised learning requirements. So you have to have the input features of training datasets. So while you're building your code, the code has to be able to collect datasets from the user. You also have to have the training datasets split into the datasets that you want to train. You have the test dataset and the validation dataset. So the dataset that you have, the original dataset, is the labeled dataset that you've provided, and then you have a test dataset that is going to test the model that you have built or the images that you've classified, and then those images are going to be tested using the test dataset, and then they're going to be validated as a final output. And like I said, while you're using these learning environments or learning models, you have to choose the correct algorithm or algorithm that works closely with these learning models. So some of the algorithms that you can use for this particular model are decision tree or k nearest neighbor. So a decision tree, and I'm going to cover this in a follow-up talk on AI, is a case where you have different features. So take a shirt, for instance. Is going to start with, does it have long sleeved? If it has long sleeved, then does it have sleeves? Sorry, let's start with, does it have sleeves? Yes. So if it has sleeves, it goes true. And while it's classified as true, the next question on the decision tree will be, is it long sleeved or is it short sleeved? So that's the general format of a decision tree. And then you can have a k nearest neighbor, which means if it has sleeves, it is more there is more plausibility that it is a shirt than it is a trouser, and then the decision runs from there. And so let's look at the types of supervised learning. So you have the regression. This is based on relationship between the input variable and the output variable. And in the case of regression, it uses these different algorithms such as linear regression, regression trees, nonlinear regression, and polynomial regression, and Bayesian linear regression. And these particular algorithms, like it has been listed here, it basically uses a plausibility factor. You know, what percentage of it is plausible, and makes that decision based on that, as opposed to classification, which is based on a yes or no case. Like I said, with decision trees or with the random forest or logistic regression or support vector machines, it is based on the yes or no question. Is it like I said, does it have sleeves? Yes, so it goes yes, it's a shirt. It's a shirt. It can be long sleeved or short sleeved. If no, then it could be a trouser, it could be a hat, it could be anything else. So these are the types of supervised learning. So then we now move to unsupervised learning. So this is a machine learning technique where the user does not need to supervise the model. And some of the types of unsupervised learning include clustering, so groups with similarities, or association in the case of relationship between variables. So let's dive into that. Some of the algorithms that you can use in unsupervised learning include k-means clustering. You have the k-nearest neighbor, hierarchical clustering, neural networks, principal component analysis. So all these are algorithms. And when we come to the practical case, or where we start doing the practicals, these are going to be more interesting, and you're going to learn more about these different algorithms. So before I jump into reinforcement learning, unsupervised learning is pretty much the opposite of supervised learning. While there are small similarities between the two, when it comes to the application of the algorithm follows a different learning process. So note with clustering, there's groups with similarities, and then with association, there's relationship between variables. This can be confused with supervised learning, where there's regression and classification. This is going, again, I'm going to repeat, this is going to be very clear when we do the practicals. So let's jump into the very final type of learning that we're going to cover in this talk, which is reinforcement learning. So reinforcement learning is a feedback-based machine learning technique in which an agent learns to behave in an environment by performing the actions and seeing the results of an action. In this case, reinforcement learning is an advanced version of unsupervised learning. Not an agent here is not a user input. This is a computer-based file, and basically it learns within an environment where it mimics the human mind. If this is correct, or this is true, or this is positive, then let me take the next step in this direction. If this is negative, let me go the opposite direction. So reinforcement learning solves a specific type of problem where decision making is sequential, and the goal is long term, such as game playing and robotics. So sequential in the sense that yes, this is correct, or this is positive, this is a positive result, so let me move in that direction, or this is a negative result, so let me go in the opposite direction. So with reinforcement learning, just like supervised and unsupervised learning, it has its own different algorithms that you could use to achieve specific results. So the first algorithm that we're going to review is Q-learning. So Q-learning is a model-free, off-policy, stochastic, and it's based on the stochastic transitions. So transitions here are random transitions, and model-free here, it means it's not based on a constricted environment. It's not based on a specific policy. The algorithm makes random choices, and based on these random choices, if there's a positive output or positive feed result, then it takes the next step, and the next step here is stochastic, which means it's random. It just makes a random move. And then if in this particular learning algorithm, the Q-learning algorithm is definitely going to have an output that is characterized by the time it takes, and also the accuracy. So if you don't want to use the Q-learning algorithm, if you find it to be expensive in terms of resources, which could be very much the case, expensive in terms of time, you could use the state action reward state action. In this case, it is a policy-based algorithm, and it is model based. So the algorithm here uses a specific model to determine what to do, what to test, what to compare these to. And it also uses a deterministic modeling, which means it is not random. It takes the next step based on the previous step. So if you make this step and this is the positive reaction, or this is the positive result, then it makes sense to take step 2. So that is deterministic, and it is determined to and it makes all these decisions in that manner. So that is the general. Those are the two very common algorithms in reinforcement learning. The third and fourth algorithm here are a general advancement of Q learning. So you're going to have deep Q neural network. You can have the Q learning explanation. So these algorithms basically advance, or they provide the user. They actually don't advance. They provide the user with different ways of achieving a result. And when we come to the practicals, it's going to be clear to you why we have these different algorithms. And this is mostly based on the variables that we want to collect, or the factors that must be considered in a particular use case. And I'll give an example. While you're working in a medical field, the expected output can be expensive in terms of resources, but it has to be accurate enough to be feasible within the industry standards of a medical field. On the other hand, when it comes to marketing, you could reduce the expense of building a sales prediction AI, because the decisions that are made by this particular model has to be added to market specialists. So the results of this AI can be adjusted if the AI suggests go in this direction, and you actually pick that direction, and along the way you figure, oh, this is not the right direction, or the market has changed. You can change the output, or you can change the decision you've made without dire consequences, for lack of a better word. So based on the industry that you're in, these algorithms are going to make sense. So for instance, you're in a robotics field, you want this robot to make decisions, and there's specific areas or different robots that you have. You're going to pick an algorithm based on the based on the use case that you have. So this being a very brief introduction to AI or machine learning, I expect that you guys have more questions, and I hope you do, on what is AI, what next, how do you go about it, how do you build the actual model. So I'm going to provide this specific talk is also going to include a hands-on guide and learning path, and I'm hoping this link is going to be provided to you. You could use this link to go on and learn more about AI. And you could also find more details on learn.flapbox.com, where there are multiple resources that you could use. Through this platform, we have implemented, or we have run through a number of partnerships that have enabled us to put together resources that are very, very critical for a learner. And it builds this learning path that is very simple based on our experience, and it's going to enable you to learn AI regardless of this, how you rate yourself, either as a beginner, an expert, or an intermediate developer. So please check out these links. I'm sure there's a session here for question and answers. Reach out to us, and if you're looking for an internship opportunity, email us at info@flapbox.com. The AI Institute has interns from multiple universities, very interesting universities, and we're looking forward to hear from you, from the DSN community. And if you have further questions, please reach out to us in the comment section, like this video, and subscribe. Thank you very much for listening. See you next time.
Thank you for this awesome section. Wow, I'm sure we have learned a lot and we start practicing what we have learned. Okay, so thank you, Doctor, for this awesome section, and thank you, everyone, for staying to the end. I'm sure you enjoy it. So, my colleagues have dropped some links that you can actually use to feed the attendance, create a community, get the book as I've earlier communicated, the AI for Beginner book. So kindly follow those links, join the Telegram group, join this group so that learning can continue. So see you next time. Thank you very much for joining. Okay, bye.